everyone. Here, that's my name. In that first slide is my name. I'm going to present to you some work in artificial intelligence, typical that's AI. Yeah, so we shall do some algorithms and some scenarios. Yeah, so we have local search algorithms. In local search algorithms, we have different types or examples. We have hill climbing. This one involves starts with an initial solution and improves it by moving to a better neighboring solution until a peak is reached. And then we have for example, we have in task scheduling, like hospital appointments, to minimize conflicts and waiting times. We have also stimulated annealing, which stimulates cooling process in order to find a near solution for by avoiding local options. Yeah, examples in urban planning. We also have other local search like genetic algorithm. This one is inspired by biological evaluation. Yeah, it uses selections, crossovers, mitigations to evolve solutions. For example, we have in resource allocation in disaster relief. For example, efficient distribution of food and medical supplies. So we're going to talk about improving usability with AI. Yeah, so we shall be talking about responsible AI and explainable AI. So responsible AI ensures AI algorithms are ethical, transparent, and free from bias. Example includes preventing bias in healthcare recommendations. We also have explainable AI, which provides clear explanations of AI decisions. For example, explaining why a specific school placement was chosen. We have different types of what? We have different kinds of local search algorithms and also ways of improving usability with AI. Yeah, so let's talk about adversary search and scenarios where it is used. So we say adversary search is a technique using AI to make decisions in an environment where agents compete against each other. So the aim of this is to maximize one's benefit while minimizing the opponent's benefits. So it's useful in the following areas, like it's useful in chess or border games. It's also useful in cyber security and other places. So we have we shall talk about minimax and expectmax algorithms as used in adversary search. So minimax is used in two-player games where one player tries to maximize their scores while other tries to minimize it. For example, in Tik-Two games. Yeah, we also have expectmax as used in adversary search. This one is used in games with an element of chance, like backgammon, incorporating probability into decision making. For example, in a game where a die rolls affects the outcome, expectmax would evaluate moves by considering both the players' strategies and likelihood of different random events. So that is like probability. So let's talk about the beta and the alpha pruning techniques. We shall talk about the alpha beta pruning techniques, examples, and the main purpose in the adversary search. Yeah. So alpha beta pruning is a technique used to reduce the number of nodes evaluated in the minimax algorithm by eliminating branches that cannot possibly influence the final decision. For example, in chess games, if one sequence of moves already results in a better score for the opponent, subsequent moves in that branch are not evaluated further. Its main purpose is to make adversary search more efficient, reducing the number of nodes that need to be evaluated, allowing deeper search in the same amount of time. So we shall talk about the concept of adversary search, adversarial machine learning. Adversarial machine learning refers to a field of research that studies how machine learning models can be attacked or manipulated by adversaries and how to make them more robust against such attacks. Like the concept focuses on how machine learning models can be attacked and how to defend them. For example, we have evasion attacks where bypassing spam filters and poisoning attacks. Basically, I gave two, but there are more than two, like two examples of other adversarial machine learning attacks. Yeah. So basically, I gave evasion attacks and poisoning attacks. Yeah. So we have the defensive strategies or mechanisms. We have adversary trainings. We have gradient masking and input sanitizations. Those are the strategies for defensive. These are defensive strategies in the concept of adversary machine learning. Yeah. So how adversary machine learning is related to universal research. It's rated in different ways, but basically I will give you two major ones: optimization and competition. That's how it is. They're related in such a manner that both fields involve optimization in the presence of competing objectives. And then in game theoretic nature, both can be framed as games with two opposing players. Yeah, thanks so much for watching my video. Don't forget to subscribe, like, and follow for more. Yeah. Thanks so much. Oh my god, everything is in it.
Does
She didn't stop.